Hey guys, welcome to part 2 of Unit 9, Lesson 1. Today we're talking about applying properties of logarithms as well as the change of base formula. Let's get into it. Alright guys, as promised, here is Unit 9, Lesson 1, part 2, all on paper. We need to go with a better system because this is going to use up way too much paper and I feel a little guilty killing all these trees, but for today it's going to be perfect. Alright, so last time we talked about converting between exponential, and logarithmic forms. I don't know what happened. Today we're going to work on applying properties of logarithms, and we're going to apply the change of base formula. So, some basic properties of logarithms. The log, it doesn't matter what your base is, any log base of 1 equals 0, because any number to the 0th power equals 1. Take a second and try some in your calculator. Anything to the 0th power is going to give you 1. If your log base and the value you're taking the log of are the same, you're going to get the value of 1, because any number to the first power is itself. Alright, so over here, if our base and the thing we're taking the log of is being put to an exponent y, we're going to get y, because b to the y power equals b to the y power, and y obviously equals y. So, when bases match log to exponential, the bases cancel and the power comes down. So, what we're looking at is right here, our bases, the log base and then the exponential base are canceling out, and then we just kind of get that y equals y. Okay, right here, when bases match exponential to log, whatever's inside of the logarithm comes out. So, again, our exponential base, this b right here, and our log base kind of cancel out, and we get x equals x. Remember I said exponents and logs kind of cancel each other out. They're inverse operations. The deal with this, though, is that our bases need to match exactly, right? When we're adding and subtracting, if I have positive 5, the only way to completely cancel it out is to take negative 5, and that brings us back to 0, right? Here, because these completely cancel out, because they're the same base, they completely cancel out, and we're just left with whatever is left over. Alright, let's try a couple. So, looking at this first one, it doesn't initially look like there's much I could do. But what if we rewrite 8, right? I know 8 is really 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So we can rewrite this as log base 2 of 2 cubed. Well, now these 2's are going to cancel out, and we're just going to be left with 3. When we cancel out the log base, we cancel out the log with it, by the way. Alright, over here, 2 and 2, these are going to cancel out, and we just get 10. This one again, it looks like we can't do much, but we need to use our brains and think about how we can possibly turn the 49 into a 7. Well, I know that 7 squared equals 49. So what if we take 7 to the negative 2? Remember, that's really saying 1 over 7 squared, which is 1 over 49. So, if we do log base 7 of 7 to the negative 2, these are going to cancel. That drops down and we get negative 2. Okay, and then this is just showing our answers. Okay, let's try some more. Right here, these are the exact same numbers, so what are we going to get? Just the number 1. Okay, right here. Remember, anything to the first power, we end up with 0, so the log base anything of 1 is 0. Right here, our log bases are going to match, so those cancel out, and this comes down, and we get to x. Okay, so this should be a review from Algebra 2, but in case we've forgotten, we've got some properties of logarithms. The first one is the product rule. Okay, so that says that any two things that we are multiplying inside of a logarithm can be separated. We keep the same log base and we put addition in between them. If we are dividing, right, same log base, we're doing some division, we can separate them out using subtraction. Whatever our numerator is becomes our first term, and then whatever's in the denominator becomes our second term. All right, last but not least is our power rule, and our power rule just says if I've got a log base of something with an exponent, our exponent can be taken and brought out in front like this. Take a second, I'd freeze your screen, write these down if you don't have them, or I believe if you double check that handy dandy formula sheet, they'll be found on there. All right, so let's practice expanding these. We're going to start. I see that this is multiplication, so I can separate them using addition. So we'll take log, and we keep our base the same of our first piece, plus log. Keep it of our second base, plus log 7. I'm sorry, I keep saying base. Of our third piece. Easy peasy. Okay, here now. We're dividing, so I know we can actually use subtraction to separate these out. I'm going to take log base 8 of x to the 4th power minus log base 8 of y to the 5th power. Now we can actually use another property, and that has to do with our exponents, right? Let's use that power rule to move these exponents out in front. So you end up with 4 log 8 of x minus 5 log 8 of y. Alright. Nailed it, crushed it. So smart. Okay. Ooh, here's another one. So, what I would honestly do with this one is I would move the power out in front to begin with. So, we've got 5 log a over b to the 3rd power. Now it's easy to see, okay, we've got this division, let's separate it out using subtraction. So 5 log a minus 5 log b to the 3rd power. Well, we don't like having exponents inside of a log, so let's take it and move it out in front. So this is 5 times 3, because we're moving this 3 out in front, log b. And then you can simplify this out. 5 times 3 is 15. Boom. Okay. Ooh, condensing these. This should be good. All right, so the first thing I would like to do if we are going to condense is to look for the power rule, because the power rule is the easiest to just kind of put back into a small chunk. So we've got this 8, we've got this 4 that we can move up. So this will be log u to the 8th plus log v to the 4th. Now, we can only combine two logs into multiplication or division if and only if the log bases are the same. So looking here, standard base, standard base. So I can combine these two pieces using multiplication because they have addition happening. So we'll have log u to the 8th times v to the 4th. And that's it. Alright, we're going to try the same process over here. We're going to start looking for the power rule. I see the 4, the 2, let's move them over. Log u to the 4th minus log v squared. All right, we have to check, do they have the same bases? They do, so we can combine them, and because it's subtraction, we're going to use division. Boom. All right, last little bit, and then I've got a bunch of practice in the Google Classroom for you. So, our special basis for our logarithms. So, our common logarithm, the base is always 10. So whenever you see just a regular old log, our base is 10. This is understood whenever you say log of something. We use base 10 in statistics and some scientists that we use to express data. It's honestly the most common one that you'll see. So another base is the natural logarithm, and that's log base e. We can rewrite it as ln for natural log. So this base of e is understood whenever you say natural log of, and we use it in a lot of sciences to examine specific like natural phenomena. To be clear, e is a number, and if you go to your calculator, we can find it right here. Do you see this button that says ln, and then up in the blue, if you hit second, it's e to the x. So if we do e to the first power, what do we get? It's 2.71828182846, and it keeps going. E is an irrational number, just like pi. So that's why we give it a letter instead of a number. But it does represent a real life number, and it stands, e and natural log will undo each other because they're the same exponent and the same value. You'll also use natural log and calculus a lot if you get to take that. So, to do any change of base, we can do a change of base to either go to base 10 or a natural log base, okay? And to do this, we have to take whatever we're taking the log of and just put it in the numerator, and we give it either log of x or natural log. Then we take the log base we were working with and say it's log of that value, or if we're doing natural logs, natural log of that value. Pretty straightforward. You might need to use the change of base to solve for a variable, and in some cases to enter logs of bases that are other than 10 or e into your calculator. When we get to doing actual calculations, I'll show you how to use your calculator. Your calculator can actually do log base of something. It's pretty cool. Alright, so let's take this and we're going to rewrite it into a common logarithm. Remember, the common base is just base 10. So I'm going to start with my 2x, log 2x. That's going to go in the numerator, over log. This was my base, so it's going to become the value right here. Right here, we're using unnatural logarithm, so that means ln. So I'm going to start with my x, ln of x. And I always write it like this because sometimes n is used as a variable, and I don't want it to look like 1nx. That's just me. Versus like over here, we don't use O and G very regularly as variables, so I know that this is log. That's just a personal thing. Okay, so now we're taking base 8, so we're going to do ln 8. Boom. All right, so there's a bunch of practice problems on Google Classroom. And once you are done with those, if you feel confident and don't want to ask me any questions, feel free to go ahead and do the assessment and hit submit. If you have any questions or concerns, feel free to shoot me an email or jot it down, and we can talk about it in our our Zoom session on Monday. I look forward to hearing from you. Do great things. Love you. Bye.